All right, hello boys and girls. It's Miss Bulky here again, and today we are going to be learning how to add and subtract using scientific notation. So we've already gone over multiplication, we've already gone over division. So there are similarities, but there are also differences, so I want to make sure that you understand why the differences are when we are adding and subtracting versus multiplication and division. So as you know from multiplication and division, what we would do is we would just take our two numbers, we would multiply them, and then we would multiply the other two, we'd add the exponents. However, this is a little bit different. Because we are adding, we cannot add two base powers of 10 that do not have the same exponent. So as you notice, this here is a 2 and this here is a 3. So before we can do anything with this, we need to make sure that we make these two equal. So right now they are not equal. So we want to either put them as a 10 to the exponent 3 or a 10 to the exponent 2. So pick one, we'll just decide to do 10 to the exponent 2. So in this case, to do this, what we would do is we have to keep this one as is, 3.4 times 10 to the exponent 2. And then let's make this number equal 10 to the exponent 2. So if we want this 4.57 to be 10 to the exponent 2, not 3, what we would need to do is we'd need to move our decimal. So we need to move our decimal to make this number here equal to what this number would be. So if we moved it to 45.7 times 10 to the 2, that should equal the same. So this would be 4,570, and this here would equal 4,570 as well. So therefore, by moving this decimal, we are able to make this number equal to this number here. Okay, so now we can deal with this. Because we are adding, we need to make sure first that these powers of 10 are the same, and now they are. So we are able to then add them together. So what we would do is we revert back just like we did with the multiplication division. We take our first two numbers, 3.4, okay, and we are now adding 45.7, and that's going to be 10 to the exponent 3, okay? We cannot change exponents, we cannot add or subtract exponents because we are adding, not multiplying or dividing. So when we are adding or subtracting, we need to make sure these two are equal. So therefore, I would take my normal addition and I would end up with 49.1 times 10 to the exponent 2. Now, what is a problem with this? Well, if we go back to our rules of scientific notation, we know that 49 is not, well, yes, it's larger than 1, but it's not smaller than 10. So we have to make this to be in proper scientific notation. So we need to then move our decimal over 1. So it would be 4.91. And because we are moving the decimal over, we have to make our number larger so they both are equal. So therefore, we would have to make it 10 to the exponent 3. So if we look here, are these the same? For 4,910, that would have been move it 2 spots. This one, I'd move it 3 spots. 1, 2, 3, and they would be equal. So this shows, this is just a quick little check to make sure that these two numbers are the same, because this is now in proper scientific notation. If at the beginning you would have changed this to a 3, 10 to the exponent 3, it would have given you the same answer. So you could pause it and give that one a try as well. I'm going to give you one more, and this is dealing with subtraction. So, okay, You can sing now or something. Go do something while I erase. All right, and we're back. So now what I'm going to do is I'm going to give you another question. I'll use blue because it kind of seems to show up a little bit better. So in this one, we have now 8.2 times 10 to the 5, okay, subtracting 3.16 times 10 to the 2. So if you want to pause it, 10 to the 2. If you want to pause it here, you can, and then you can give it a try on your own. So do that now. And we're back. So I have taken into the account of this, we have 8.2 times 10 to the exponent 5 minus 3.16 times 10 to the exponent 2. So in this case, I'm decided I like 5. I'm going to keep both of them together as a 10 to 5 to make both of these two numbers equal. Okay? So what I have to do here is I'm going to keep the 8.2 times 10 to the exponent 5. I'm going to keep that as is. Then I'm going to subtract, and now I have to change my number here to make it 10 to the exponent 5. So I need to make this number equal to if I was making it 10 to the exponent 5. So what I would do, because I'm making this a larger number, I have to move the decimal to the left. I might need to make it a smaller number so it has more spots to move to equal 3.16 times 10 to the 2. So here it would be 0, and I'm 10 to 5, so I have 3 spot difference. So I have 1, 2, 3 spot difference. Okay, so that would be my new number. So I have 0.00316 times 10 to the exponent 5. Then what I'm going to do with this is I go back to what I have been working with by going 8.2. Now I'm subtracting 0.00316, and then all of that will be times 10 to the exponent 5. And when I get the answer from this, it would equal 8.196 times 10 to the exponent 5. Now looking at this, if your teacher or if I want you to round this, then you can also round this to make it 8.2 times 10 to the exponent 5. Okay? If you had decided to do the same thing, but you wanted to make them both 10 to the 2, exponent 2, you would have had to move the decimal, this decimal spot 3 times to the right, okay? And then you would have had to do conversion, so you should have ended up with the same number. I suggest you try it again using the other 10 to the power, so maybe try making them both to 10 to the exponent 2. So give that a try, see if you get the same answer. We'll practice more when you come into class tomorrow. All right, have a good day. Bye.